Okay, Ashley. Yeah, this problem of getting these equations into the graphing calculator is tricky. It's very tedious. Before we go on, let me just clear up a little mistake over here. This should be 16t squared. I'm going to go over this in a minute, but I just want to clean things up a little bit. Okay, 16t squared. Okay, so I admit that I got a little careless, a little sloppy with some of the work I did the other day or yesterday. Obviously, these are long equations, complicated in many cases. And what I found is if I'm writing out the equation and doing my work while I'm recording, I guess I can't help but feel a little bit rushed and a little bit careless because I'm trying to finish the video. So anyway, I've written out the equations. So this is the worksheet problem 3. And it's Francesca in the Ferris wheel. And so these are the x1, whoops. x1 is Francesca's x-coordinate, y1 is her y-coordinate, x2 is the ball's x-coordinate, y2 is the ball's y-coordinate. Okay, so just go through these. I've made a few changes. I've switched to radians rather than degrees. Not sure that makes a difference, but that's what I did. So anyway, x1 is 20. That's the radius of the Ferris wheel. That's where that comes from. And her x position is, x-coordinate is going to be related to cosine of pi over 6. That's the 30 degrees times the quantity 1 plus t. And that's because she starts off at 30 degrees. That's where the 1 comes from. And then every second adds another 30 degrees, or pi over 6. So I hope that makes sense. That's x1. That's pretty simple now. y1, again, pretty simple. That's 26. That's the height of the center of the Ferris wheel, plus her the addition to the y-coordinate has to do with the turning of the Ferris wheel. And this, of course, is very analogous to over here, so hopefully that makes sense. 20 times the sine of pi over 6 times the quantity 1 plus t. Okay, x2 is the ball, and it's 75, of course, starts because it's 75 feet away from the origin in the x direction. 60 times cosine of 2 pi over 3 times t. That's the change in the x-coordinate due to the velocity of the ball in the x direction. And y2, the y position coordinate of the ball, starts out at 6 feet, and you add the change due to the velocity in the vertical direction of the ball, which is 60 times sine of 2 pi over 3 times t, and then you subtract the effect of gravity. Okay. So when you do x1 minus x2, so we're getting ready to graph this, and we want to determine the distance as a function of time between Francesca and the ball. So x1 minus x2, that's pretty straightforward. x1 minus x2, this is what you get. Oh, I know. The other thing I did, I simplified. I saw that cosine of 2 pi over 3 is just negative 1/2. So just to make it a little simpler to enter stuff into the graphing calculator, I simplified that part. So 60 times negative 1/2 is negative 30t. So x1 minus x2, we got this. This is x1, and this is minus x2. So it's minus 75, but then the minus 30t becomes a plus 30t. Okay, so we're going to put that into the graphing calculator and square it, and then we're going to add to that quantity, we're going to add y1 minus y2 squared. y1 minus y2 is, well, 26 minus 26 minus 6, that's where the 20 comes from. And then you just bring this down, and then you subtract 60 times the sine of 2 pi over 3 times t. But now this minus 16t squared up here becomes a plus 16t squared because of this minus sign here. Well, excuse me, I'm not saying it right, but you get the idea. This is a minus, whoops, this is a minus, but this quantity, 16t squared, is a minus 16t squared. That becomes plus 16t squared. Okay, so now we're ready. Of course, we're going to have to square this whole quantity. So I'm going to end this video here. Now we have the equation in a reasonably workable form. I'm going to close this video, and I'll do another video on the graphing calculator.